Hey guys, Space Marine 658 here. We're going to be talking about fuzzy searching as well as regular searching inside of Unreal Engine. It can be a little complex, so I wanted to cover it in as approachable way as I can. So starting off, we're going to talk a little bit about just the basic bare minimum setup you need to get started. For those of you following my quest system, this isn't necessarily integral, but you don't need to follow the quest system to basically all you need is an edible text field here. For those of you who have been following, what I've gone ahead and done is just surrounded our quest log with a vertical box, then added a size box that surrounds a border that surrounds an edible text field. This is where the players will actually enter in their search terms to actually go ahead and take a look. And as you can see here, I'm doing it on text changed. So let's actually pull that up and show off what the final results should look like. So for example, here I have two quests, one of which has a description that includes the words squanch. So I start typing it, as you can see here, depending on what I actually have input here, it's going to try and match that as best as it can. Now I've set a score limit, of course, so that way it tries to return the absolute best match. As you can see here, it's returning test because squanch is in its description. But if, for example, I typed in quest 1, there's no word quest inside of that test 1. And so it tries to match as closely as it can to what's being typed in. So how do we do that? Well, the first thing we're going to want to do is once you've got your search editable text field in here, we're going to want to create a C++ function. But what it's going to do to just kind of show you guys from a blueprint point of view, this is the simple version. I'm going to show you two different versions, a simple and an advanced version. But essentially you're going to pass in these items to search. And what this is an array. So to get this array for myself, what I've gone ahead and done is basically just start off by clearing it out, getting all the searchable quests. So whatever you want players to search on, you'll want to gather. So for me, I've gone ahead and gathered every single quest in my game and then just added unique to this all searchable quest because of course I don't want to search duplicates. Now I've only added active, available, and completed quests. You could also do this for unavailable or just all quests in general. It depends on how you want your search functionality to work. If you're not doing quests, let's say you're doing a RTS Wikipedia, you'd want to include things like title, description, maybe you'd have like tags related to each item, things you'd want them to be able to search over. You could, in theory, have them search over absolutely everything. Just be aware that the more your text is searching over, the more things are probably going to get returned as you're searching, depending on how specific you are. Now, with this, we're basically going through here and we're generating those search terms. So as you can see here, I'm grabbing the name, description, and then the titles of different objectives, and then plugging them all in and combining them. I'm doing it this way so that way I'm searching one string, one text all at once rather than searching a whole bunch because it's a little bit easier on the system to do it in this way. Now, once I've generated my search terms, what I'm going ahead and doing is I'm actually calling the search with a basically with the as you can see here on text change editable text that passes out a text field. I'm just converting it to a string because the backend will work a little bit better with string. And then I'm doing a little bit of checks here to make sure, hey, is my length greater than 0? That means it found something. If yes, then I'm updating what my search options are. If false, then because I'm going to actually delete this, make that more clear. If false, then it just returns print string not found. There's a couple of things you can do there as well. For example, on my more advanced search, I'm doing that not found, but then I'm also clearing out the children and adding just a quest collection widget that says no results found. So that way, when players are playing, they get a little bit of feedback here. So for example, if I just start typing in, you can see no results found. But let's actually dive into the code now and sort of talk about what this actually looks like. So what I've gone ahead and done is if you go and create a C++ class, what you're going to want to do is hit new C++ class, all classes, and there's something called a blueprint function library. So we go blueprint function library. If you like this content and you'd like to see more C++ classes or blueprints or whatever you'd like to see, make sure to subscribe and definitely leave a comment down below with what you'd like to see. A lot of times this content I come up with is from suggestions from viewers like you, or stuff that I come up on my own. The more suggestions I have, the easier it is to make videos on it. This is what you're going to want to use as your base class, mostly because it is relatively empty and there doesn't come with a whole lot of stuff. And so what I've done is I've created that, and then I added a couple of includes up here. So by default, by having it be a blueprint function library, it comes with core minimal, Kismet, and then the actual generated.h. What I've done is include the C standard input output, C string, C type, and C dint. Basically, these are all very useful things. You may not necessarily need all of these depending on if you tweak the functions or not. So we've got 3 functions, one of which is an internal private function, one that's not exposed to blueprinting. It's a static bool match simple. What this static means is that we can call this from anywhere in the engine. This isn't related to a specific class or a specific character or anything like that. This is just a function that is designed to be standalone. Then it's returning a bool, and what it's booling is basically, hey, does this pattern and string have a match? If yes, then bool. And then down below we have a U function, 2 of them, and what this is doing is this is just making it so that Unreal Engine can see the blueprint callable function here and can actually do something with it. We've given a category as well called custom functions. I do this with all of my functions that are in a function library, just to make them all in one place I can look at them. Now, as you can see, these are 2 very different headers though. So as you can see, they start out the same. So you have static, you have tarray int 32. What this is this is the index of the returned item. So for example, if you have 5 things that you're searching over, it's going to say return 2 and 4. Those are your 2 indexes that you can then know to return to show on the front end. And then we have the names, search and advanced search. And then over here, they start out the same. So they both have an F string array called items. And then they both have F string search text. And what this is going to do is this basically are the 2 main important things. The search text is what the player actually typed in. The items is what's looking over. And then the advanced search has a minimum score. What this does is this filters out anything below that minimum score won't get returned. And just as a heads up, I am going to include all this code in the description down below. So if you want to follow along and watch and understand, but not necessarily have to type it all out yourself, you can copy that code as well. Not to say my code is perfect. There's definitely probably some people out there that could make my code better. This is just what I currently have. All right, so let's look at the first one because this is sort of in the other 2 functions. And so let's actually talk about this one. So this is match simple. Basically, it has a while loop. This while loop goes through while the pattern does not equal endline character, and while the actual string that we're comparing to does not equal endline character. It's going to go and look at to lower basically means that there's no capitalization. This is just to make sure that there are times, for example, in the advanced search where you're going to want to compare if it's capitalized or not and assign points based on that. But for the simple search, for the most simplest version of this, we don't actually care about that. And so what's going to do is it's going to look at the pattern, it's going to look at the string, it's going to compare them, and then if they match, so if they're equal to each other, it's going to increment the pattern. Whether or not they are, it's still going to increment the string that you're passing in. From there, it's going to then return the pattern, does it equal a endline character? If yes is true, then it's going to return true. If not, it's going to return false. So what this essentially is doing is it's going to keep going over this and over this and over this, and looking for that endline character. If the pattern has the endline character, that means that you've incremented through the pattern all the way to the end, which means you found matches. If it doesn't, so instead the string that's typed in, you've reached the endline character, that means instead that you have gone through the entire string without finding a match. And that's the most core principle for the match symbol. So if we go and look at our initial, this is our simple search, as we'll call it. What this is doing is it's got our matching indices, which is our, results, as you call it, as I called it in the advanced search. For this one, it's very short code, so I left it matching indices. But for this one, I figured it's going to be pretty complex, so I'm going to call it results. So for this one, and then we've got our index here. The reason why I do an index is this code's a little bit easier to read and understand. And so I'm not a big fan of doing for loops in the what I call the other way. And so this one's a little bit easier for me to read and understand. So with this, we go through every single one of the items that we're sending in this array. We're saying each one of them is an F string, and we're going to call them item for each time we pass through. So think of this kind of like a for each. It basically works like a for each. And so for each item in items, we want to go if match simple, and then we want to pass into our match simple, which takes a pattern and a string, of course. We want to pass in our search text and our item. Now, what's happening here is we want a const char so that we can increment over every single letter in this search. But Unreal Engine at the U function level doesn't allow for const char, so you need to have it be an F string. So to convert that from an F string into that const char, we basically just go in here and have this ANSI char string cast that converts it with a get. Basically, it grabs this and converts it over. And we do that for both of these. And then basically what's happening here is match simple is going, okay, true or false, do these match? If true, then we're going to say, hey, this has a match. If not, it's just going to carry on and increment. And so what this is doing is it's going through each one of these and say, hey, do these have at least a matching character? If yes, then that counts as a match, and return all the indices of everything that has at least a matching character. And so with this is great for a very, very simple search, something where you're not necessarily worried about them wanting to do anything complex. In the example we gave in here, even if I typed in, let's say test, depending on what exactly is in Quest and all that, this might actually show up under that with that simple search, because it's just designed to be very simple, just like at least a letter matches. So the T in Quest would match the T in test, therefore it would show up, and vice versa. Now, of course, this is great for just very simple searches, but if you're wanting to do something more complex, we have our advanced search down here, which this is a bit of a beast. So I'm not going to get too heavy into the specifics, but if you want to look at the code, it's included down below, but we'll also kind of cover it very briefly here as well. So this one, what we're doing is we've got our results. This is our indices in the previous search. And basically we're ahead of time just converting our search text to ANSI. And then we're also going to score some constants. These are basically ways for us to say, hey, here's how many points I assign to each one of these things happening. For example, the camel bonus versus separator bonus versus sequential bonus basically allow us to say, hey, if it has this, give it this kind of points. And then what we're doing is recursively, we're going to go in and actually compare these letters. We need to do it recursively because we're giving scores to things based on the entire string. So whether the match is at the beginning or the end, we want to make sure that we're recursively checking each and every single one of these types of options and assigning points based on that. So that way we get an overall score of how much it is. And so with that, we go ahead and early, this is all functions and Lambda implementations, just everything needed to actually set up for the code to actually run. So for example, all this is just part of that greater function. So you can see here, this is all basically one big function in the most simplest terms. Then what we do is we set the outmatches to empty to make sure everything's ready to go. And then we're going to go in and actually call that function. So we have our result, which is just a Boolean, true or false. And then we're going through and we're matching recursively, and that's going to return that Boolean to result. Once we have that result, we go in and we go, okay, we've got a result if this matches or not, this specific one. Then we need to go in and for the out matches, we're going to add if this was a match, essentially. So if true, we're going in and adding, okay, this one matched. And then once we're done, we're going to return the result, the Boolean, right? And that all gets returned up to this main function. So this auto fuzzy match. And so once that's done, that's processed all of the different strings that we've passed into it, checked all of them against their scores and everything, and just given each one of them a score. Then we got to come down here and basically go through each and every single one of the items. So we go number of items, which I did in the other way in this because I wanted, this is a little bit easier to understand in terms of the item's length. And we've gone and we're going to go to that string cast and we're getting a string pointer, item pointer. We're going, hey, this score equals 0. Get all the create an array of matches. Okay, so I do still use the uint8. I couldn't remember. It's been a little bit since I've written this code. And then we're going, okay, grab our fuzzy match. And then basically what we're doing here is with all these pointers, we're going, okay, what is the score of these? Which one of these matches? And then we're going to go and score as long as all of this adds up. This basically generates a score. Is this greater than that minimum score? If so, then we're going to actually finally add it to the result. So we've got our results is where we're actually going to get all of those indices. So as long as the score is greater than the min score, that gets included. So the reason why this is important to have that minimum score is it allows you to flexibly tweak how accurate you want your fuzzy search to be. The lower the score, the more broad and generalized it will be until you get to the point where you're just returning everything versus having that results be our min score be very high means it's less and less likely to return anything except what you want it to return. Now, part of that depends on the actual score constants here that you assign, because technically they don't have to be these numbers. You can set them to basically whatever you want. Because, for example, these all combine to equal 90, and then with this one that makes it 100. Versus you have these, which are combined to equal -21. So in theory, 79. If you got perfect for all of these somehow, and then also got all of the penalties, -79 would be the highest possible score you could score. But you may want to set that to a higher limit, just because, not necessarily will you get all, but then also miss some of these. But yeah, so that is everything for this. Like I said, below is going to be the code. But let's actually go take a look at how we then implemented that code into here. Now for the simple search, that one was pretty straightforward. You give it to items search, you give it to the actual string of the search text, and then you do whatever you want to with this search update. So this, for me, this is updating the UI, which I'm going to do a video about for our Quest folks. But for anyone using this in your search, this is where you can do your hey, here's what matches, here's what I need to return. For the advanced search, we do things a little bit differently. If the search is blank, then we want to reset the UI. If it's not, then we want to do our advanced search where I've set it to a minimum score of 90. From here, we want to check, is this greater than 0? If true, then we call that search update where we're going to actually update the UI. If it's false, so that nothing was returned, then we're going to want to go ahead and clear the children out of our quest log and add a new item. But of course, depending on what you're doing for your project, it will be different. But yeah. So that's pretty much it for fuzzy search versus simple search. But if you have any questions, definitely leave them down below. I know this is a pretty complex topic. It's something I still sometimes have a hard time wrapping my head around. But it is a very useful one for things where you need to allow players to search. But yeah, I think that's it for today. If you have any questions, let me know. Otherwise, good luck and good hunting.